December 15, 1943. Blum and Voss Shipyard, Hamburg. Naval constructor Wilhelm Brenner stared at the production report that would haunt his nightmares for the rest of the war. The statistics painted across his desk told a story of industrial triumph turned into maritime catastrophe. U-boats completed, 742. U-boats operational, 178. U-boats lost to enemy action, 564. What Brenner was witnessing was the mathematical collapse of Nazi Germany's most ambitious naval program, an industrial machine that had produced over 1,100 submarines, only to watch 783 of them disappear beneath the waves of the Atlantic Ocean. This single production report would reveal how the Third Reich's underwater fleet had become the largest submarine graveyard in naval history, taking 30,000 German submariners to their deaths in a war they were mathematically destined to lose. Operation Seawolf had begun with Hitler's promise to starve Britain into submission through unrestricted submarine warfare. The plan was mathematically elegant. German U-boats would sink Allied merchant shipping faster than it could be replaced, severing the supply lines that kept Britain fighting. Admiral Karl Dönitz, commander of the U-boat fleet, had calculated the precise requirements for victory. Germany needed 300 operational submarines to maintain continuous Atlantic patrols. Each U-boat would sink an average of 100,000 tons of Allied shipping before being lost to enemy action. At this rate, Britain's merchant marine would be eliminated within 18 months. The mathematics seemed achievable. German shipyards could produce submarines at unprecedented rates using revolutionary construction techniques. Prefabricated hull sections, assembly line welding processes, and standardized component manufacturing promised to launch new U-boats every few days. But the Allies possessed mathematical advantages the German planners never anticipated. American shipyards were constructing Liberty ships faster than U-boats could sink them. British intelligence had cracked German naval codes, providing advance warning of submarine positions. Most critically, Allied anti-submarine technology was evolving at rates that German submarines couldn't survive. The stage was set for the largest submarine war in history, a conflict where industrial capacity, technological innovation, and mathematical precision would determine which side controlled the Atlantic Ocean. Captain Friedrich von Steinberg stood on the conning tower of U-427 as she prepared for her maiden voyage from Kiel Naval Base. At 29 years old, von Steinberg represented the new generation of U-boat commanders, university-educated, mathematically trained, and fanatically committed to Dönitz's vision of submarine supremacy. U-427 embodied the pinnacle of German submarine technology. Type VIC construction, 769 tons displacement, armed with 14 torpedoes and an 88-millimeter deck gun. Her pressure hull could withstand depths of 220 meters. Her electric motors provided silent running at 4 knots. And her experienced crew had trained for 8 months in Baltic Sea operations. But U-427 was also evidence of Germany's growing desperation. Her steel contained inferior alloys due to material shortages. Her batteries used substitute chemicals that reduced underwater endurance. Most critically, her crew averaged only 19 years of age. Experienced petty officers were becoming increasingly scarce as submarine losses mounted. Executive Officer Hans Müller had survived 2 previous patrols aboard U-203, making him a veteran by 1943 standards. His experience provided sobering perspective on German submarine operations. Herr Kapitän, we are the 427th U-boat commissioned. Of the first 300 boats, fewer than 50 remain operational. The mathematics are not encouraging. Von Steinberg understood the statistical reality, but refused to acknowledge its implications. Müller, we represent German industrial superiority. Our shipyards are producing submarines faster than the enemy can sink them. Every month, we grow stronger, while they grow weaker. The conversation revealed the fundamental delusion driving German submarine strategy. Production statistics created an illusion of strength that masked the mathematical reality of unsustainable losses. Across the Atlantic, Lieutenant Commander William Harrison of HMS Starling was studying German submarine construction reports obtained through intelligence intercepts. Harrison's anti-submarine group had sunk 11 U-boats in 6 months, and his analysis revealed disturbing trends in German capabilities. Their no-boats are better constructed, but poorly crewed. Construction quality is declining due to material shortages and rushed production schedules. More importantly, experienced personnel losses are forcing them to deploy submarines with inadequately trained crews. Harrison's assessment highlighted the human cost of Germany's submarine war. Each sunk U-boat represented 45 to 50 trained submariners, specialists who required months of instruction and years of experience to achieve combat effectiveness. German training facilities were producing new crews faster than veteran instructors could properly prepare them. The German submarine construction program achieved industrial miracles that impressed even enemy intelligence analysts. Between 1940 and 1943, German shipyards completed submarines at rates never before achieved in naval history. Blumenvoss Hamburg led the production surge with revolutionary construction techniques. Traditional submarine building required 12 to 18 months per boat. German engineers reduced this timeline to 6 months through prefabrication, standardized components, and assembly line procedures borrowed from automotive manufacturing. Naval constructor Brenner supervised construction of 247 submarines at Hamburg alone. His innovation in modular hull construction allowed simultaneous work on multiple submarine sections, dramatically reducing completion times. We are not building submarines. We are manufacturing victory through industrial precision. The production statistics were staggering. By December 1942, German shipyards were launching new submarines every 3.2 days. Kiel Naval Shipyard completed 89 U-boats in 1942. Bremen-Vulkan Shipyard launched 67 submarines. Hamburg-Blumenvoss delivered 72 boats. Smaller facilities contributed additional vessels, creating a submarine fleet larger than all other navies combined. Worker productivity reached levels that seemed impossible under wartime conditions. Submarine construction required approximately 150,000 man-hours per boat using traditional methods. German efficiency experts reduced this requirement to 89,000 man-hours through improved welding techniques, precision tooling, and optimized workflow management. Quality control became the hidden weakness in Germany's production miracle. Rushed construction schedules created systematic defects that wouldn't become apparent until submarines encountered combat conditions. Inferior steel alloys caused hull failures at operational depths. Substitute rubber compounds deteriorated rapidly in seawater. Electronic equipment failed due to inadequate testing protocols. Technical Inspector Klaus Weber documented these problems in classified reports that never reached senior naval commanders. Production quotas are being achieved through compromised construction standards, Weber warned. Submarines completing acceptance trials may fail catastrophically during extended operations. Weber's concerns were systematically ignored as production targets took precedence over engineering reliability. The mathematical logic was seductive. More submarines meant greater offensive capability, regardless of individual boat quality. U-427's first patrol began on January 12, 1943, with orders to join Rudel Pack Wolf operations in the North Atlantic convoy routes. Captain von Steinberg commanded a crew that had never experienced combat conditions, sailing waters where experienced U-boat commanders were being killed at unprecedented rates. The voyage to operational areas required 14 days of careful navigation through increasingly dangerous waters. Allied air patrols had achieved nearly complete coverage of submarine transit routes. RAF Coastal Command aircraft equipped with improved radar systems could detect surfaced U-boats at ranges exceeding 20 miles under optimal conditions. U-427's first encounter with enemy forces came on January 28, when RAF Wellington bomber W5847 detected her radar signature while running on the surface to charge batteries. The aircraft's attack demonstrated technological advantages that German submarine doctrine couldn't counter. Pilot Officer James Morrison had been hunting U-boats for 8 months, perfecting attack techniques that achieved kill rates exceeding 40%. His Wellington carried 4 250-pound depth charges set for shallow detonation patterns designed to crush submarine pressure hulls through coordinated shock waves. U-boat diving, attack approach initiated. Morrison's radio transmission was monitored by Allied intelligence services, providing real-time tactical information about German submarine movements. Every encounter generated intelligence that improved subsequent anti-submarine operations. Captain von Steinberg ordered emergency diving procedures, but U-427's descent rate had been compromised by construction defects that wouldn't be discovered until too late. Her ballast tank vents operated 15% slower than design specifications due to inferior valve manufacturing. Emergency diving time, 47 seconds instead of the standard 35 seconds required for survival. Morrison's depth charge attack bracketed U-427's position with mathematical precision. 4 explosions in perfect sequence, each detonation calculated to maximize pressure hull damage. The submarine's inferior steel construction couldn't withstand coordinated shock waves that would have been survivable in earlier, better constructed boats. U-427's pressure hull cracked in 3 locations, allowing catastrophic flooding that overwhelmed damage control procedures. Emergency ballast systems failed due to electrical damage from the attack. The submarine sank by the bow with 23 men trapped in flooded compartments. Captain von Steinberg and 22 survivors reached the surface, where they were rescued by HMS Starling 3 hours later. Their interrogation would provide Allied intelligence with detailed information about German submarine construction defects and crew training inadequacies. Executive Officer Mueller's testimony revealed the scope of Germany's submarine crisis. Our boats are being built too quickly, the steel is inferior, the equipment fails under combat stress, and our crews lack sufficient training. We are sending boys to die in submarines that cannot survive enemy attacks. The capture of U-427's crew provided Allied intelligence with unprecedented insight into German submarine operations. More critically, Mueller carried operational documents that revealed the mathematical scope of Germany's submarine construction program. British intelligence analyst Sarah Whitfield studied the captured documents with growing amazement. The papers detailed production schedules showing German plans to complete over 1,000 submarines by war's end. Construction rates, crew training programs, operational assignments, a complete intelligence treasure that exposed every aspect of German submarine strategy. "They're building submarines faster than we imagined possible," Whitfield reported to Admiral Max Horton, Commander-in-Chief Western Approaches. "But the intelligence reveals critical weaknesses. Construction quality is declining, crew experience is inadequate, and their operational losses are higher than our previous estimates." The captured documents revealed that German submarine losses were approaching 60% of all boats deployed on combat patrols. Such casualty rates were mathematically unsustainable, regardless of production capacity. Germany was consuming trained submarine crews faster than training facilities could replace them. Allied cryptographers had simultaneously achieved breakthrough success against German naval codes. Bletchley Park's specialized submarine tracking section, directed by mathematician Alan Turing's improved bombs, was decoding German naval communications within hours of transmission. Every U-boat departure order, every patrol assignment, every tactical modification was being intercepted and analyzed by Allied intelligence. German submarines were sailing into battles where their enemies possessed complete knowledge of their positions, capabilities, and intentions. Commander Roger Wynne, director of the Admiralty's submarine tracking room, had created the most sophisticated anti-submarine intelligence operation in naval history. His team tracked individual German submarines across the Atlantic, predicting their movements with accuracy that seemed impossible to German commanders. "We know every German submarine is located," he reported to Churchill during weekly intelligence briefings. "More importantly, we know where they're going and when they'll arrive. Our convoys are being routed around submarine positions before the Germans realize we've detected them." The intelligence advantage was overwhelming. German submarines were being hunted by enemies who could predict their movements, counter their tactics, and position attack forces with mathematical precision. May 24, 1943 would become known as Black May in German submarine records, a month when Allied anti-submarine forces achieved kill rates that devastated the U-boat fleet. The statistics told a story of technological obsolescence that German naval commanders refused to acknowledge. U-boat losses for May 24, 1943. 43 submarines sunk, 1,935 submariners killed, 6 boats damaged beyond repair. German submarines had achieved their lowest success rates since the war began, sinking only 34 merchant vessels while losing nearly 2,000 trained personnel. Captain Werner Hoffmann of U-934 transmitted the final radio message that would summarize Germany's submarine crisis. "Under continuous air attack, cannot dive due to damage, request immediate assistance." His transmission was intercepted by Allied direction-finding stations that triangulated U-934's position within minutes. HMS Kite and HMS Woodpecker arrived at U-934's position while the submarine was still attempting emergency repairs. The ensuing surface engagement lasted 17 minutes, ending with U-934's complete destruction and the loss of all 48 crew members. The technology gap extended beyond detection systems. Allied weapons technology had achieved similar revolutionary advances that made submarine destruction mathematically inevitable once detection was achieved. The Allied development of the Hedgehog anti-submarine mortar represented a paradigm shift in submarine warfare tactics. Unlike traditional depth charges that exploded at predetermined depths, Hedgehog projectiles detonated only on contact with submarine hulls, eliminating the acoustic interference that had previously allowed damaged submarines to escape. British Admiralty research had determined that traditional depth charge attacks achieved kills in fewer than 6% of encounters. The Hedgehog system achieved kill rates exceeding 40% through contact fusing that guaranteed accurate damage assessment and immediate follow-up attacks. Captain Frederick Walker, commanding HMS Starling, had refined Hedgehog attack techniques that achieved unprecedented destruction rates against German submarines. His mathematical approach to submarine hunting treated each encounter as a geometry problem with calculable solutions. Submarine evasion follows predictable patterns based on depth limitations, speed constraints, and human psychology, Walker explained to his officers. By calculating probable evasion responses and positioning Hedgehog salvos accordingly, we achieve hit probabilities that approach statistical certainty. Walker's methods had been systematized and distributed throughout the Allied anti-submarine fleet. Every escort commander now possessed tactical manuals that reduced submarine hunting from intuitive art to mathematical science. The Squid anti-submarine mortar, developed as an improvement to Hedgehog, could fire 3 projectile salvos with automatic depth settings calculated by advanced fire control computers. These weapons achieved hit rates exceeding 60% against maneuvering submarines, making survival mathematically improbable for German U-boat crews. American research had simultaneously perfected the Mark 24 Fido acoustic torpedo, the first successful homing torpedo designed specifically for anti-submarine warfare. Dropped by aircraft, these weapons actively pursued submarine targets using acoustic guidance systems that made evasion nearly impossible. The Fido torpedo had been tested under strict secrecy, achieving kill rates approaching 80% against submarine targets in controlled conditions. When deployed operationally in March 1944, the results exceeded even optimistic projections. Lieutenant Commander James Russell, commanding USS Bogue's anti-submarine aircraft, achieved the first operational Fido kill against U-488 on March 18, 1944. His after-action report described weapon performance that rendered traditional submarine evasion tactics meaningless. Torpedo maintained pursuit through multiple course changes, depth variations, and emergency maneuvers. Target destruction was inevitable once weapon acquired submarine acoustic signature. By early 1944, Allied cryptographic capabilities had achieved complete penetration of German naval communications. The Ultra Intelligence Program, processing German Enigma intercepts through advanced computational methods, provided Allied commanders with strategic intelligence that bordered on telepathic capability. Commander Roger Wynn's submarine tracking room had evolved into the most sophisticated naval intelligence operation in military history. His team maintained real-time awareness of every German submarine's position, mission assignment, fuel status, and operational condition based on intercepted communications and traffic analysis. We possess more complete information about German submarine operations than German commanders themselves, Wynne reported to First Sea Lord Admiral Andrew Cunningham. Our convoy routing decisions are based on submarine positions that German headquarters doesn't know we've detected. The intelligence advantage had become so overwhelming that Allied convoys were routinely avoiding submarine patrol lines before German submarines reached their assigned positions. U-boat commanders reported increasingly frequent encounters with empty ocean, patrol areas where intelligence had promised convoy traffic that never materialized. Captain Zerze Hans Rudolf Rusing, commanding the 11th U-boat flotilla, documented the psychological impact of systematic intelligence failure. Our submarines report constant encounters with enemy forces that appear to anticipate our movements. Patrol areas that should contain convoy traffic are empty. Enemy attacks occur at times and locations that suggest complete knowledge of our operational plans. Allied intelligence had also achieved breakthrough success in German industrial espionage. British agents operating within German shipyard facilities provided detailed reports on submarine construction schedules, technical modifications, and quality control problems. These reports revealed that German submarine construction was achieving quantity at the expense of reliability. New boats were completing trials with systematic defects that would prove fatal under combat conditions. Hull welding standards had deteriorated, electrical systems were failing at unprecedented rates, and torpedo firing mechanisms were suffering malfunction rates exceeding 30%. Dr. Sarah Thompson, directing technical intelligence analysis for the Admiralty, had compiled comprehensive assessments of German submarine vulnerabilities based on captured equipment and interrogation reports. Enemy submarines constructed after mid-1943 exhibit systematic weaknesses in pressure hull integrity, electrical reliability, and weapons systems functionality. Their construction shortcuts are creating inherent failure points that our weapons can exploit with mathematical precision. March 1944 marked the beginning of what German submarine historians would later call the Great Dying, a period when Allied submarine forces achieved kill rates that eliminated German submarines faster than mathematical probability suggested possible. The monthly statistics told a story of technological obsolescence that German commanders could no longer rationalize. German submarines sunk in March, 37 boats. German submarines damaged beyond repair, 12 boats. Allied escort vessels lost, 2 ships. Allied aircraft lost to submarine action, 1 bomber. German submarine crew casualties, 2,156 men. Allied anti-submarine casualties, 47 men. The casualty disparity revealed the complete transformation of submarine warfare from contested battle to systematic extermination. German submarines were being destroyed at rates exceeding 85% while inflicting casualties lower than peacetime training accidents. Captain Heinrich Lehmann-Willenbruch, commanding U-25-6, transmitted one of the final tactical assessments that accurately described German submarine conditions. Enemy detection capabilities have rendered underwater operations impossible. Surface running results in immediate air attack. Submerged operations are tracked by unknown detection methods. Request permission to abandon patrol and return to base. Lehmann-Willenbruch's transmission was intercepted by Allied direction finding stations and decoded within 40 minutes. HMS Vedette and HMS Woodpecker were vectored to U-256's position based on radio triangulation, arriving while the submarine was still attempting to withdraw from her patrol area. The engagement lasted 12 minutes. U-256 was destroyed by hedgehog attacks that achieved 6 direct hits on her pressure hull. Lehmann-Willenbruch and all 49 crew members were killed when the submarine imploded at 180 meters depth. Similar encounters were occurring throughout the Atlantic with clockwork regularity. German submarines that had once operated with confidence in their stealth capabilities found themselves hunted by enemies who possessed overwhelming technological and intelligence advantages.
Captain Friedrich Eugenberger, one of Germany's most successful submarine commanders, provided the final assessment that would doom Operation Seawolf. Mein Admiral, we are no longer fighting a war we can win. Enemy technology has achieved advantages our tactics cannot overcome. Every submarine mission is now a training exercise for Allied anti-submarine forces. Admiral Dönitz received Eugenberger's report during a conference that would determine the future of German submarine operations. The assembled commanders represented the surviving elite of the U-boat fleet, men who had witnessed the transformation of submarine warfare from German advantage to German catastrophe. Gentlemen, our submarines have sunk over 3,000 Allied vessels, Dönitz addressed his commanders. Our industrial production has created the largest submarine fleet in naval history. Victory requires only persistence and continued sacrifice. The mathematical reality contradicted Dönitz's optimism. German submarines were achieving kill rates barely 20% of their 1942 performance, while suffering losses that eliminated experienced crews faster than training could replace them. But the true scope of Germany's submarine disaster was only beginning to emerge. By January 1944, Allied intelligence would discover the stunning mathematical reality. Of 1,162 U-boats constructed by German industry, 783 would ultimately be destroyed by Allied forces. The industrial miracle that was supposed to win the war had instead created the largest underwater graveyard in naval history.
The commander Otto Krestmer, Germany's highest-scoring submarine ace before his capture in 1941, provided perspective on the tactical transformation from his British prison camp. Our submarines once hunted enemy ships using superior tactics and crew training. Now our boats are hunted by enemies using superior technology and complete intelligence. The roles have been reversed, and the mathematics favor our destroyers. German naval research desperately attempted to counter Allied technological advantages through revolutionary submarine designs that promised to restore underwater superiority. The Type 21 electroboat program represented Nazi Germany's most ambitious attempt to regain submarine warfare effectiveness. Professor Helmuth Malter, directing advanced submarine development at Germanische Kiel, had designed submarines that promised performance characteristics far exceeding conventional diesel-electric boats. The Type 21 could achieve 17 knots submerged speed, operate underwater for extended periods without surfacing, and carry advanced detection equipment that might counter Allied radar systems. Naval constructor Otto Merker supervised construction of the first operational Type 21 boats using prefabrication techniques that promised to complete advanced submarines in record time. These boats will restore German submarine superiority through technological advancement rather than numerical production, Merker assured Admiral Dönitz during prototype demonstrations. The mathematical projections seemed encouraging. Type 21 submarines could outrun Allied escort vessels while submerged, dive to depths that rendered depth charge attacks ineffective, and operate independently for weeks without surfacing for battery charging. If produced in sufficient quantities, these advanced boats might restore German offensive capability in the Atlantic. But production reality contradicted theoretical promises. The first Type 21 submarines suffered systematic defects that prevented operational deployment. Advanced electrical systems failed due to component shortages. High-speed underwater propulsion systems proved mechanically unreliable. Most critically, construction schedules required skilled labor that Germany no longer possessed. U-2511, the first operationally deployed Type 21, suffered catastrophic electrical failure during sea trials that killed 8 crew members and forced emergency surfacing within sight of Allied patrol aircraft. Her commander, Kapitänleutnant Adalbert Schnee, reported construction defects that rendered advanced capabilities meaningless. The boat cannot achieve design specifications due to systematic component failures. Advanced technology is worthless if basic engineering reliability cannot be maintained. The Type 21 program would ultimately complete 118 boats, but fewer than 4 achieved operational status before Germany's surrender. Advanced submarine technology couldn't overcome industrial collapse and material shortages that prevented reliable construction. Summer 1944 witnessed the systematic destruction of Germany's remaining operational submarine fleet through Allied anti-submarine operations that achieved near-perfect success rates. The technological and intelligence advantages had become so overwhelming that submarine encounters resembled training exercises rather than combat engagements. Captain Johnny Walker's 2nd Escort Group achieved unprecedented success during this period, sinking 23 German submarines in 4 months without losing a single escort vessel. Walker's mathematical approach to submarine hunting had been refined to scientific precision that rendered German evasion tactics predictable and ultimately futile. Enemy submarine commanders follow tactical patterns that our analysis has reduced to mathematical formulas. We can predict evasion responses, calculate optimal attack positions, and achieve weapon solutions with certainty that approaches 90%. German submarines are no longer combatants. They are targets following predetermined behavioral patterns. The human cost of Germany's submarine disaster reached catastrophic proportions during summer 1944. Monthly casualty reports documented the systematic elimination of an entire generation of German naval personnel through submarine operations that achieved no strategic objectives. Oberleutnant Wolfgang Lüth, commanding U-181, wrote final letters that captured the psychological state of doomed submarine crews. We sailed knowing that return is mathematically impossible. Enemy technology has achieved advantages that render our boats obsolete. Yet duty requires continued sacrifice, even when sacrifice serves no strategic purpose. U-181 was sunk by HMS Wren on July 15, 1944, using hedgehog attacks that achieved 9 direct hits. Lüth and all 54 crew members died when the submarine's pressure hull collapsed. His letters were recovered from floating debris and forwarded to German families through International Red Cross channels. The psychological impact on surviving German submarine crews had become so severe that medical facilities reported widespread refusal to report for duty. Men who had volunteered for elite naval service were requesting transfer to infantry units rather than face submarine deployment that promised certain death. Admiral Dönitz attempted to maintain morale through propaganda, emphasizing German technological advancement and ultimate victory through persistence. His speeches to submarine crews promised revolutionary weapons that would restore German supremacy. The mathematical reality told a different story of systematic failure that no technology could overcome. By autumn 1944, German submarine construction faced material shortages so severe that production quality deteriorated beyond operational requirements. Strategic bombing of German industrial facilities had disrupted supply chains essential for submarine manufacturing. Naval constructor Brenner's production reports documented systematic failures that rendered new submarines operationally useless. Steel quality has declined to levels insufficient for pressure hull construction. Electronic components are failing at rates exceeding 60%. Torpedo systems are experiencing malfunction rates that prevent weapon firing. We are producing submarines that cannot perform basic operational requirements. The material crisis extended beyond component quality. Skilled labor shortages forced German shipyards to employ inexperienced workers, whose welding and assembly techniques created systematic defects throughout submarine construction. Quality control inspections revealed failure rates that should have prevented any boat from completing acceptance trials. Technical Inspector Weber's final classified report provided devastating assessment of German submarine construction. Current production methods are creating submarines with pressure hull integrity insufficient for operational depths. Electronic systems failed during basic maneuvers. Weapon systems cannot be fired reliably. These boats represent industrial waste rather than military assets. Weber's warnings were ignored, as production targets took precedence over engineering reality. The mathematical logic remained seductive. More submarines meant greater offensive capability, regardless of individual boat reliability. Training programs faced similar collapse as experienced instructors were killed faster than replacements could be trained. Submarine schools were graduating crews with instruction periods reduced from 12 months to 6 weeks. Technical competency had deteriorated to levels that made operational deployment essentially suicidal.
Commander Friedrich Steinhoff, directing submarine training at Danzig Naval Academy, reported unprecedented problems with new crews. Students cannot master basic technical systems in abbreviated training periods. Navigation instruction is insufficient for ocean operations. Most critically, psychological preparation cannot address the mathematical reality that submarine deployment equals certain death. December 1944 marked the statistical moment when German submarine losses exceeded all reasonable military justification. The cumulative casualty figures revealed the scope of naval disaster that had consumed an entire generation of German maritime personnel. German submarine losses since January 1940. Total submarines constructed, 1,162 boats. Submarines lost to enemy action, 652 boats. Submarines scuttled or surrendered, 131 boats. Submarines currently operational, 47 boats. Personnel casualties, 28,744 killed, 5,249 captured. Strategic objectives achieved, statistically insignificant. Allied losses to German submarine action during the same period. Merchant vessels sunk, 3,500 ships. Naval vessels sunk, 175 warships. Personnel casualties, 36,200 civilian sailors, 5,150 naval personnel. Strategic impact insufficient to affect war outcome. The mathematical comparison revealed that German submarine warfare had achieved tactical success while failing strategically. Allied replacement capabilities had overcome German sinking rates through industrial production that rendered submarine attacks economically irrelevant. Captain Otto Kähler, one of the few surviving submarine commanders with operational experience dating to 1940, provided final assessment of German submarine strategy. We achieved the impossible by sinking over 3,000 enemy vessels, but impossibility was insufficient. Enemy industrial capacity replaced every ship we sunk while producing weapons that made our continued existence mathematically improbable. Admiral Dönitz faced the statistical reality that submarine operations were consuming Germany's most valuable naval personnel without achieving strategic benefit proportional to the losses. Each submarine deployment represented 45 to 50 trained specialists whose expertise couldn't be replaced under wartime conditions. The broader strategic implications extended beyond naval operations. Germany's submarine program had consumed resources equivalent to constructing 2,400 fighter aircraft or 800 main battle tanks, weapons that might have provided greater strategic benefit than submarines that achieved 60% casualty rates. Professor Dr. Wilhelm Deist's post-war analysis would conclude that German submarine construction represented one of the war's most catastrophic resource allocation decisions. The submarine program consumed strategic materials, skilled labor, and industrial capacity that could have produced weapons with greater tactical effectiveness and lower personnel casualties.
Professor Samuel Eliot Morrison's official history would conclude that submarine warfare represented the most mathematically decisive campaign of World War II. German U-boats came closer to achieving strategic victory than any other Axis weapon system. Their ultimate failure resulted not from lack of courage or competence, but from mathematical impossibility created by Allied technological and industrial advantages. The technological lessons proved equally significant. Radar development, cryptographic intelligence, advanced weapons systems, and coordinated tactical doctrine had transformed submarine warfare from a contest of stealth and courage to scientific application of mathematical advantage. Future naval conflicts would belong to forces capable of achieving similar technological integration. The industrial implications established precedents that would guide naval construction for decades. Mass production techniques, quality control procedures, and strategic resource allocation decisions developed during submarine warfare would influence shipbuilding industries throughout the Cold War period. In the depths of the Atlantic Ocean, 783 German submarines rested on the ocean floor alongside the dreams of naval supremacy that died with their crews. Their sacrifice had achieved tactical victories that proved strategically meaningless against enemies who possessed overwhelming advantages in every aspect of maritime warfare. The mathematics of submarine warfare had proven more decisive than the courage of submariners, the skill of commanders, or the ambition of admirals. In the age of industrial conflict, victory belonged to nations capable of producing weapons faster than enemies could destroy them, while simultaneously destroying enemy weapons faster than they could be replaced. Germany had built 1,162 submarines. The Allies had sunk 783 of them. The difference represented the margin between tactical achievement and strategic victory in the mathematics of modern warfare.
The pattern was becoming mathematically predictable. German submarines were being detected, tracked, and destroyed with clockwork precision by Allied forces that possessed overwhelming technological and intelligence advantages. Aircraft attacks accounted for 60% of German submarine losses during May 1943. Improved radar systems, longer-range patrol capabilities, and devastatingly effective depth charges had transformed Allied air power into the primary submarine killing force in the Atlantic. Captain John Walker, commanding the 2nd Escort Group, achieved unprecedented success rates during this period. His formation of 6 destroyers and corvettes sunk 12 German submarines in 4 weeks using coordinated attack tactics that exploited every weakness in German submarine construction and training. The enemy submarines are no longer the threat they once represented, Walker reported to Admiralty commanders. Their boats are poorly constructed, their crews are inexperienced, and their tactical methods are predictable. We're achieving kill rates that would have been impossible 18 months ago. Walker's assessment reflected the mathematical transformation of Atlantic submarine warfare. German production quantity couldn't compensate for qualitative disadvantages in construction, training, and technology. Behind the statistics of submarine warfare lay individual stories of young men dying in underwater metal coffins, far from home and family. The human cost of Germany's submarine program created a generation of naval widows and orphan children whose sacrifices achieved no strategic benefit. Oberlieutenant Klaus Richter, age 22, commanded U-634 during her final patrol in June 1943. His last letter home revealed the psychological pressure facing German submarine crews. Mutter, we all know that most boats never return. The enemy finds us too easily, attacks too effectively, but we continue sailing because duty demands sacrifice, even hopeless sacrifice. U-634 was sunk by Canadian corvette HMCS Chambly on June 18, 1943. Richter and 46 crew members died when multiple depth charges crushed the submarine's pressure hull. His mother would receive official notification 3 months later, fallen heroically in service to the fatherland. The psychological impact on surviving submarine crews was devastating. Men who had volunteered for elite naval service found themselves trapped in death traps, sailing missions with survival odds lower than Russian roulette.
Medical reports from German naval hospitals documented widespread nervous disorders, depression, and refusal to report for duty. Commander Heinrich Schroeder, a veteran of 12 patrols, described the transformation of German submarine service. "We once hunted enemy ships with confidence in our superiority. Now we are hunted animals, cowering underwater while enemy aircraft circle overhead. Our young crews are terrorized before they ever encounter the enemy." Training facilities reported unprecedented problems with new recruits. Men would volunteer for submarine service, complete basic training, then request transfer to other branches rather than face operational deployment. The submarine service, once considered the elite assignment in the German Navy, had become synonymous with suicide missions. Admiral Dönitz attempted to maintain morale through propaganda, emphasizing German industrial superiority and technological advancement. His speeches to submarine crews promised new weapons, improved boats, and ultimate victory through persistence. The mathematical reality told a different story. By late 1943, German submarine construction had achieved rates that seemed to validate Dönitz's strategy. New boats were being launched every 2.8 days, creating the illusion that production was outpacing losses. The reality was more complex and ultimately more devastating. Naval constructor Brenner's production reports revealed the hidden costs of accelerated construction schedules. Material quality continues declining. Steel alloys contain increasing percentages of substitute materials. Electronic components fail at rates triple those of earlier production boats. Our submarines are completing construction trials but failing operational requirements. Quality Control Inspector Weber documented systematic construction defects that were being ignored to maintain production quotas. Hull welds with insufficient penetration, electrical systems using substandard components, periscope assemblies with optical defects, torpedo tubes with dimensional inaccuracies that prevented weapon firing. "We are producing submarines that cannot survive combat conditions," Weber's classified reports warned. Construction shortcuts are creating systematic weaknesses that enemy forces are learning to exploit. Our boats are sinking due to construction failures as much as enemy action. The warnings were systematically dismissed by production managers focused on meeting Hitler's submarine quotas. Mathematical logic suggested that more submarines meant greater offensive capability, regardless of individual boat reliability. Worker productivity had reached levels that required systematic use of foreign labor, prisoners of war, and conscripted personnel who lacked shipbuilding experience. Submarine construction quality suffered accordingly, with defect rates increasing monthly throughout 1943. Training programs faced similar pressures. Submarine school curricula were compressed from 12 months to 6 months to provide crews for increased production rates. Technical instruction was simplified, practical experience was reduced, and graduation standards were lowered to meet personnel requirements. The mathematical equation was becoming clear to Allied intelligence. German submarine construction might achieve impressive quantity, but quality deterioration and crew inadequacy were creating targets rather than threats.
The technological lessons proved equally significant. Radar development, cryptographic intelligence, advanced weapon systems, and coordinated tactical doctrine had transformed submarine warfare from contest of stealth and courage to scientific application of mathematical advantage. Future naval conflicts would belong to forces capable of achieving similar technological integration. The industrial implications established precedents that would guide naval construction for decades. Mass production techniques, quality control procedures, and strategic resource allocation decisions developed during submarine warfare would influence shipbuilding industries throughout the Cold War period. In the depths of the Atlantic Ocean, 783 German submarines rested on the ocean floor alongside the dreams of naval supremacy that died with their crews.
Their sacrifice had achieved tactical victories that proved strategically meaningless against enemies who possessed overwhelming advantages in every aspect of maritime warfare. The mathematics of submarine warfare had proven more decisive than the courage of submariners, the skill of commanders, or the ambition of admirals. In the age of industrial conflict, victory belonged to nations capable of producing weapons faster than enemies could destroy them, while simultaneously destroying enemy weapons faster than they could be replaced. Germany had built 1,162 submarines. The Allies had sunk 783 of them. The difference represented the margin between tactical achievement and strategic victory in the mathematics of modern warfare.